Now, Ruby also has this concept called modules. And the idea behind modules is a container for classes, methods, and constants. In a way, module is like a class, but module cannot be instantiated. So a class essentially inherits, so the class inherits from a module class and adds a new method. So a class you can instantiate by calling a new method on the class, but module you cannot instantiate. So for example, if you do IRB and then you do class.ancestors to see the ancestors of a class, you will see a hierarchy where you have a class which extends from module, which extends from object. As we saw, everything extends from object. And then object extends from kernel, and then basic object. So a module serves two main purposes. It either serves as a namespace or as a mixin. So let's explain these two concepts here. So to use a module as a namespace, why would you do that? So for example, you have a class ruler. Well, what kind of a ruler is this? Is this a ruler that you have in your toolbox, or is this a ruler of a country? So the class name is just ruler, but you could namespace it by saying it belongs to a module toolbox and have it inside of that module, or it belongs to a module called country. And then you'd use this funky operator, this colon operator, to instantiate the class. So then you would say toolbox ruler.new, and then you're talking about this toolbox, the toolbox ruler, as opposed to the country ruler, which belongs to the country module. So that's the first concept of modules. It's namespace. The other concept that modules are used for is mixins. And to explain what a mixin is, think of a Java interface. It's a contract. It defines what a class could do, behavior of a class, but actually mixins are much cooler than that. Because in Java, for example, an interface is just an interface, just a contract, doesn't have any behavior behind it. But a mixin is like an interface, but it has behavior, it has the actual code behind it as well. And it could be used among multiple classes. So this sort of serves this idea of multiple inheritance. So you can inherit from multiple classes, but you could have multiple modules mixed in. And then the cool part is that you could include built-in modules from Ruby, like enumerable or comparable, which can do all the hard work for you and add a lot of behavior to your class out of a box. So for example, let's see what a mixin is altogether. So let's say you have a module that's called a naming thing. And all this module does is it has an accessor called name, and it has a method called printName that lets you basically print out the value of that accessor, of that name instance variable. And you could also obviously to set the name, you would do equals and then the value of a name. And you could also do .name, which would get you a value as well. And you could have an empty class person or an empty class company that just includes that naming thing module. And then what it lets you do is you automatically get this behavior of this module for free, right? So then you could do person.new to instantiate a person, to assign the name, and then print name, which is the method that's defined in this module above. And you could do the same thing for a company, right? So now company.name equals so and so, and then you could print out that name. So the idea is the person in the company doesn't inherit from that class, but it includes the behavior of those modules. And as I mentioned, you could have built-in modules that Ruby defines that you could use. So for example, the methods like map, select, reject, detect, they're being used by an array class, but they're really not part of an array class itself. They're part of this enumerable module that array class includes. And the cool part is you yourself could also include that module in your own class and get their behavior. And specifically with an enumerable module, the only method you really need to implement for this module behavior to work is each. Once you implement the each method, you get all this other behavior of map, select, reject, detect for free. So let's see an example of that. Let's say you have a class called team. And obviously the idea of a team is that it has players. Now, but you don't want to have an array of players. You want to have a team class. So your team class includes the enumerable module, which is just a Ruby module, or that's already available. And then you have, let's say you have a name and an array of players inside the team class. So you initialize it, then you could add the players, as many players as you want, using the splat syntax. And then the toString just lets you print the names of the players. And you implement this each method, as I mentioned. The only method that you have to implement for enumerable to work is this each method. And the way you implement it is you say players.each, and there's this yield syntax, which is explained later, but I'm not going to explain that now. But the point is you only have to implement the each method. And then let's say you also have a player class, and the player is name, age, and the skill level. And then you initialize it with those values, and you print out the name, skill level, and age. Right? So again, you have a team class that has players in it, has an array of players that you could add. And you have a player class where each player has a name, age, and a skill level. So then you could have a bunch of players, right? Let's say, a bunch of players here, but you initialize with a name, age, and a skill level. And then you have a team that just has a name, and then you could add those players to that team, right? So now you have your team with players. Okay, so now what could you do now? So you could, let's say you want to select a bunch of players based on their age and skill level. So only select these players between the ages 14 and 20, and reject players below a certain skill level. Right? So you could use these methods from an enumerable module. So you could do red team select and pass in a block, because that's a behavior of a select method in the enumerable module. You pass in a block with a player to check if a player is a certain age. So you select only these players, and then you reject players that are below a certain skill level, and you have your eligible players. So you all of a sudden got yourself a bunch of players from that team that you are interested in. So it has tremendous potential, this enumerable module and other modules, as we're going to see, that you could just include them in your class and get their behavior for free. So the other one I mentioned is comparable module. It provides the class with a behavior for comparison operators. So less than, greater than, and methods like between. And for this to work, you only need to implement this funky operator, less than, equal to, and greater than, to use it in your own class. So how would you do that? Let's say you have a person class that includes this comparable module, which is a built-in Ruby module. So you have a name and an age, which are your instance variables and your getters and your setters. Then you have your constructor, and then you implement this method, this less than, equal to, greater than method, to compare things. Because by default, it wouldn't know how to compare people, right? Do you compare them based on their height, based on their age, right? So you're defining this method here, and you say that, no, in this particular case, I want to compare people based on their age. So then what you could do is you could instantiate a bunch of people, Joe, Joel, and Rich, and then let's say you want to sort those people, right? So in the unsorted version, you just print all those people the way they were defined in the array, right? So you have Joe, Joel, and Rich. Doesn't matter what their age is. And this syntax over here of an ampersand equals name is just a short version of passing in a block that says, map, and then the first parameter to a block, which is a person, and then person.name. This is just a shortcut to say, and it only works if what you're doing is you're passing in a parameter, and then you take you basically call the getter on a field in that class. So in this case, it's a person class, person.name. So it would be a little longer. So that's why I'm using this shortcut notation of just doing ampersand colon name, which does the same thing. But in essence, what you're doing is you're printing out the people in this array, you're mapping them to just a name. You're printing their names, and you're printing them out. But let's say you want to sort them. So you could do is you could sort them, and then you could reverse sort them, and again, based on this comparable module, because it actually knows how to sort them. What are you trying to sort them by? And then print them out. And then you would get Joe, Rich, and Joel in a specific order, in a descending order, because you first sorted it upwards, and then you reversed it, so now you get your descending people in the descending age order. The another thing you could do is you could call a between method on the person. So you could say, take a person in the array and find out if he is between person 1 and person 0. And obviously, you mean the age because you've included the comparable module and you implemented this method that says compare people by age. So that's how modules work. Now, so far, I just showed you examples of how you use this, how you use the methods from a module if you want those methods to be instance methods of a class. So then you use the include syntax. So include includes the module's methods as instance methods of a class that you're implementing. Now, what if you want to include modules methods, but not as instance methods, you want to include them as class methods? So then instead of using the include method, you use the extend method. So let's see an example of this. Let's say you want to have a module called a finder module that basically you could say find by name, pass the name, and find this thing that you're looking for with a name. So you do it to lowercase, downcase, and Ruby calls it downcase instead of lowercase. So you do thing.name downcase, and you compare it to the name that you're looking for. And you're using the detect method. So how would you do that? So let's say you have a dog class that would extend the finder module. So you're not including it, you're extending it. So this find by name method is a class method, not an instance method. Okay, so now what could you do? So you have a dog instance. So in the dog constructor, you instantiate the dog, and you right away pass this dog to a things method. So dog.things, and you have this things method, which is a class method, which basically just keeps adding to the things class array. So @@ means that this things is not an instance variable, it's a class variable, and you have this things array that you keep adding to. So things is an array that starts out being empty, and then you keep adding the dog instances to that class variable @@ things. And then you keep adding those dog instances, and now let's say you want to search through those dog instances. So let's say you have red, blue, and green dog instances, and then you want to call find by name on a dog class, right? So in this case, it's not a dog instance, it's a dog class that you're calling the find by name method. And the reason why it's a dog dog class method is because you use the extend syntax to bring in these methods of this finder module as a class method, not as an instance method. So you could do find by name, pass in the value that you're looking for, that gives you the instance of a dog back, what you're looking for, and then dot name prints out the actual value.